Hi, today I'm going to show you how to use the L298N and L293D and B motor drivers with Arduino. These motor drivers are really simple to use. You can use it with an Arduino Uno, Nano, Mega, or any Arduino that has digital I/O pins. This L293B chip can control two motors at the same time. The L293D and B chips have this exact same pinouts, so you can just pop in L293B on a circuit that works with L293D or vice versa. The pinouts are, as I said, exactly the same and are very easy to use. One side drives one motor and the other side drives the other one. The only difference between the L293B and the L293D chips are the current capabilities. The L293B, which is this chip right here, and this one is the L293D, the L293B can handle up to 1 amp or 1.2 amps on each motor. This means that the L293B chip can drive a single motor at 1.2 amps continuously. The chip can change the motor's speed based on the PWM signal that you're inputting into, and it can also change the motor's direction. With two control pins, you can control the motor's direction, and with an enable pin, you can also control the motor's speed with PWM pins on the Arduino Uno, Nano, or Mega. While the L293B can support up to 1 amp or 1.2 amp of motor current for each side or each channel, the L293D is a weaker chip. It can only support up to 600 milliamps per channel or per motor. If you exceed that 600 milliamp rating, the chip will overheat and may likely to break or get damaged. However, there is also another rating on these chips, which are the peak current ratings. These peak current ratings are for when the motor starts turning. When it was in the non-moving state, it needs to draw more current than its continuous current to start up, like so. Or if your robot, for example, is going back and it needs to immediately ramp up the motors to go to the front, it also will draw a peak current of the motor's continuous currents about double of. So if your motor draws, for example, 1 amp while running continuously, it can draw up to 2 amps or 3 amps peak. This peak current is 2 amps on L293B maximum. You can say, what if we attach a motor that continuously draws 2 amps to the L293B? Will the chip handle it? The answer is no, because the peak currents are obviously for peak and short-term current driving. If your motor draws more than 5 or 10 seconds of the peak current, the chip can get damaged. However, as I said, the L293D is a weaker chip. This means it also has a reduced peak current. The L293D can have a peak current up to 1.2 amps or 1200 milliamps per channel, that is. And if you draw more than 10 seconds of this current, the chip can overheat significantly and get damaged. It can also damage your motors if it applies way too much voltage or breaks the motors. What I mean by breaking is applying the same polarity to the each ports of the motor, basically trying to turn the motor to each direction at the same time, like the motor's trying to turn left and right at the same time. You can do this as a break on the Arduino code. Actually, there are, as I said, 2 pins that are controlling the motor, which 2 pins are like 1 pin. If you input voltage high, it turns the motor into one direction, and the other pin turns the motor to the other direction when you set the pin to high. This will make more sense once we look at the code. But if you make the input 1 and input 2 both at the same time high, the motor will go into a braking mode. You can use this function as a brake or an emergency stop on your motor or your robot. But it is not recommended for you to brake your motor using the brake function, as I told you with the chips function. The motor can overheat if you leave it at brake for more than 10 seconds, 15 seconds, which may cause damage to your motor and permanently burn it out, because the motor draws a lot of current through the motor driver when braking, and it can damage your motor and drain your battery quickly. So we talked about the differences between L293B and D chips. L298N, however, can drive up to 2 amps per channel. It can supply 2 amps to each motor, which in total can draw up to 4 amps when it comes to the total power draw, which would heat up the chip a lot. And they attach a heatsink like this, and it's on a nice little H-bridge PCB, and it's got these screw terminals for attaching your motors like this. Very nice. And there is the voltage input and output. Yes, this has a voltage regulator on it, so that you can power your Arduino with this if you're like inputting 12 volts to it and you want to drive your motors at 12 volts, but you also don't want to use the Arduino's built-in power regulator, or you're using a model that doesn't have a power regulator like the Pro Mini. In that case, you can just use the output of the 5-volt regulator on the board, which is plus 5 volts, which is the third terminal to the right. This is the plus 12. As you can see, it says 12 volts, but you can use it from 4.5 volts to up to 38 volts, as I know. And there's the ground connection. And there is the signal connections. Here is input 1, input 2, input 3, input 4, enable B, and enable A. The enable A and enable B are covered with these short circuit little jumpers, as you can see. If you remove them like so, it will expose the enable A and enable B pins right here. They're enable B and enable A. These enable A and B pins are basically the standard enable pins on the L293D and B. The enable pins are shorted to 5 volts with these jumpers, so you can use the input pins only, which if you're gonna only use the input pins, you may need to use 4 PWM pins to control the motor's speed on each direction. But if you have less PWM pins that you can use, you can just take these off and wire the enable A and enable B pins to the Arduino's PWM pins, which will allow you to control the motor's speed, and the input pins will control the motor's directions. This will make more sense when we look at the datasheet of the L293D and L293B, which is exactly what we're going to do now. As you can see here, there is the enable 1 pin, input 1, output 1, ground pins, which are like these 4 pins are completely for ground, output 2, input 2, VCC, which is the chip's voltage input, VCC2, the chip's other voltage input for the other side of the chip, which is the other motor driver side, input 4, output 4, the ground connections, output 3, input 3, and enable 2. As I said, you can use the enable pins for driving the motor's speed, controlling the motor's speed. You can also do the same thing by using the input pins and wiring the enable pins directly to 5 volts, which is made with the jumpers on the L298N board. As you can see, the enable 1 and enable 2 pins are completely jumpered to 5 volts, short circuited to 5 volts, and you will need to use 4 PWM pins for your robot to go back, go right, go left, go front. And you also, if you also need to control the motor speed, you need to use 4 PWM pins. But if you need to reduce the PWM pins to 2 because you don't have enough of them on your board, you can just control the speed via enable pins, and which require only 2 PWM pins, and the input pins will be only used for the motor's direction. Let's look at the code. Here we define the motors right here with integers. Here the motors are set to output with pin mode, and here we digital write motor write 1 high, which is the input 1 for the L293D. We're using the D chip on the board for demonstrating how you can swap the chips over to D and B, but this is basically just not important for our use case. Then we have a delay of 2000 milliseconds, which is 2 seconds, and then we digital write motor write 1 low, which is basically turning the motor to one side and then turning the motor off. And then, as you can see, motor write 2, which is the input 2, which makes the motor turn to the exact opposite side of input 1, which we did right here, as you can see. And basically the first motor will turn to, for example, right, and then stop, and then turn to the other side. And then after this we look at the code, and there's motor left 1 right here, high, low, there's a delay. Digital write motor left 2 this time, not 1, which means input 3 and input 4 on the chip. This will make the other motor this time around turn to left and then stop, turn to right, basically. Let's look at our circuit. So here I have an 18650 lithium-ion battery powering the motors, and we have 2 motors right here connected to the motor driver. And here's the Arduino. If you're going to use a different power supply for your motors to be driven, like I did right here, you need to connect the ground pin of your external power supply to the Arduino's ground pin. Otherwise, the signals may not be sent properly and your motors would not work properly. But if you're driving the motors and the motors are low powered enough to be driven through the Arduino's voltage regulator, you can do that too. And in that case, if you basically just don't use an external power supply, you don't need to attach the other power supply's ground pin that you don't have. So let's connect the Arduino to the computer. This is just an 18650 battery holder that has an XL6009, a TP4056 for protecting the cell against short circuits. There's a JST connector for the external power right here, and a little switch that enables the XL6009, which is just a step-up converter. So we turn the switch on. As you can see, the motor is turning to one side and the other side, and then we jump over to the other motor. It turns this way and then stops and turns this way, as you can see. So our code works perfectly fine. This motor, as I said, is a little bit damaged, so it needs a little bit of help to get started. As you can see, our circuit works perfectly fine as we want it to. So if we just cut the power, just pull out the L293D like so from the breadboard. It's not even in the breadboard anymore, so we're just gonna pop in the L293B chip this time around to show that the pinouts are the exact same and it does not differ on each one, like so. And when we are going to power it on, the circuit is going to work perfectly fine. As you can see, this motor turns, then to the other direction it needs a little bit of help, and the other motor goes to one direction and then to other direction, basically. So it's this simple to use the L293D and B chips. I didn't demonstrate how to use the L298N for not making the video too long, because it may get too boring, but it's basically the same technique as the L293D and B. You just need to wire up your motors, wire up the power connection, and your your motor driver signals to the Arduino. If you're going to use the enable pins, hook them up to any PWM port on the Arduino that you're using. If you're not going to use motor speed control, you can just hook the input pins only and leave the jump parts on the enable pins, like so. It's that simple. It's very simple to use three of these motor drivers, and it's completely compatible with any Arduino that has a power input through the digital pins. This information is going to be very useful for our future robots, where we're going to be mostly using these motor driver chips, and on most small robot motors we're only going to use the L293D because it's capable enough for driving small motors like this, but no problems. The only other difference between these three chips are the prices, of course. The L293D costs the cheapest, and the L293B is a little bit more expensive, and the most expensive one is the L298N. So this is how you use L293D or B chips or L298N motor drivers with the Arduino. Thanks for watching. If you found my videos useful, please consider subscribing and don't forget to like my videos. This is Arduino Atölye'm. See you on the next video.